In this video we are going to focus on one of LINQ's most versatile and powerful features, the select method. I mentioned in the previous video that select is a project method. So, before we explore the select method, it's essential to understand the projection concept. Let's break it down. In the world of LINQ, projection refers to the transformation of objects in a collection into a new form. This doesn't mean altering the original objects. Instead, projection creates a new sequence, where each element has been transformed based on a specified criteria or function. For instance, imagine you have a list of employees in form of a table. Each employee has properties like name, department, and salary. With projection, you could transform this list to create a new sequence, maybe just the names and departments, or perhaps calculating a new field like annual salary. This ability to shape data into a new form is incredibly powerful in LINQ. It allows us to tailor our data precisely to our needs, whether for display in a user interface, for further processing, or for generating reports. A simple analogy would be making a fruit salad. You start with whole fruits, the original collection, and you transform them into bite-sized pieces, the projected collection, to create a salad. In LINQ, projection lets you chop and mix your data to suit your requirements. Now that we have a good grasp of what projection is, let's delve into how the select method in LINQ allows us to perform these transformations with ease and flexibility. Select method projects each element of a sequence into a new form. I already explained select clause in a previous video. I mentioned there that you can use select clause in query syntax and in mixed syntax. Now, the select method can be used in method syntax and in mixed syntax. Let's do a small recap of method syntax. In method syntax, we chain together extension methods to form a query. The select method is one such extension method, and it serves a specific purpose, to project each element of a sequence into a new form. Let's see it in action. Suppose we have a list of employees. Using the select method, we can easily extract a list of names. Here's how simple it is in code. This single line of code is powerful. It iterates through our employees, takes the name property of each, and projects it into a new sequence of just names. So, I had the names as rows inside a table, and now I have them as string array. I only selected the names from the table. But select can do more than just pick out properties. It can also transform data in more complex ways. Suppose I have now the following table. For example, if we want to calculate the yearly salary including a bonus of the employee John, we can do that as following. Here I am filtering the table to get only the employee John. After that I am selecting the salary, multiplying it by 12 months and adding the bonus. The result will be yearly salary including the bonus. So, we have a table as input and the output is one value, which is calculated based on different values. Now that you have seen the select method in action, let's explore its various overloads and understand how to leverage them to make your queries even more powerful. Stick around, as we will be diving into that next. Select method comes with two overloads that provide us with different ways to project our data. These overloads are part of what makes the select method so versatile in LINQ. The first overload is what we typically use when we want to transform each element of a sequence into a new form, without considering the element's position within that sequence. It follows this pattern. In this pattern, source data is your original collection, and element represents each individual item within that collection. For example, if you have a collection of data rows, element represents each data row inside the collection. The lambda function passed to select dictates how each element is transformed. So, using this lambda function we define what to select and how. I will show you how to use this overload in a real use case later. Now, let's talk about the second overload, which is slightly different. This overload not only allows you to project each element into a new form, but also provides you with the index of each element in the source sequence. This can be particularly useful when the position of the element is needed for the projection. It's like the index we have in 𝗲 method, which represents the index of the element. In this example, index is a zero-based index of element within the collection source data. This allows you to do things, like numbering items or applying conditional logic based on whether an item is at an even or odd index. Let's now have a look on some examples to understand both overloads. I will start with the first overload with a simple example. Suppose I have the following integer array, where I want to get only the numbers that are greater than 3. Here's the query to do that. As you can see, I used 𝗪𝗲 method to filter the array. The result of 𝗪𝗲 method will be the following collection, that contains only the numbers greater than 3. After that I used select method to select these numbers. So, here I have again the same collection. Both collections are of type 𝗖𝗵𝗽𝗀𝗀𝗀. At the end I used toArray method, to convert the result again to array. As you can see, both collections of 𝗪𝗲 and select methods are the same. So, there is no need to use select method. I can use this query for example, and the result will be the same. In this case the select method is optional, because I am selecting each element from the sequence without modifying the data. Let's check another example, where we have to use select method. Suppose I want to filter the array again and return only the numbers greater than 3. But now I want to multiply each number with number 2 before returning the result. Here's the query to do that. The first part of the query is the same. The result of 𝗪𝗲 method will be the following collection. After that I use select method with the following expression. As you know, element parameter represents each number inside the collection. So, this expression means that I want to multiply each number of this collection with the number 2. Using select I will get the following collection, where each number is multiplied by 2. The result of the query will be this collection. In this case, I have to use select method, else I will not be able to get this result. As you can see, I can set any expression I want using the element parameter, to transform the sequence into a new form. I used element as parameter name, but I can use any name I want, such as x, number, file, etc. Let's check another example about a data table. Suppose I have the following table, that contains information about products. I want to get a string array, that contains the product names, where the product price is smaller than 20. Here's the query to do that. First I define the source data, which is the table I want to filter. After that I used 𝗪𝗲 method to filter the table, to return only the products with a price smaller than 20. At the end I used select method to pick out the data I need. First I defined a parameter called row that represents the rows. This parameter can be used such as data row, because it represents data rows. I use the parameter with the column name, product name. This expression returns the content of the column as string. So, select method returns the following collection, that contains only the following names. This collection is of type 𝗖𝗵𝗽𝗀𝗀𝗀. At the end I use toArray method, to convert the collection to array of string. So, the result of the query is the following array. As you can see, I transformed the data into a new form using select method. I had a table as input and I got an array as output. The array contains only specific data from the table. This is how to use select method with a table. Let's now check another example using the second overload of select method. Suppose I have the following XML file. It contains different customer elements, where each element has 2 child elements, name and city. I want to get a list of the cities with the index of each element. For example, the first item in the list should be as following. 1 indicates that this city is the first one in the XML file. And then I have the city name. The next element should be 2 with the city name, and so on. Let's see how to do that. First I will read the XML file and store it in a variable called xdoc. Next I have the following query to resolve the task. The first part is the source data I want to query. This means, we are now at these positions. After that I use the second overload of select method. I define 2 parameters. The first one, x, represents the customer elements. The second parameter, index, represents the index of the customer elements. The first customer element has the index 0, the next one has the index 1, and so on. Let's now take a look at the expression. First I want to calculate the index. I added 1 to the index, to get the first index as number 1, the next is number 2, and so on. Then I have double point. At the end I use the x parameter as following. As mentioned, x represents the customer element. So, this expression means, I want to get the value of the element city from each customer element. At the end I used a list method, to convert the output to list type. The result of this query will be the following list of strings. As you can see, I used both parameters to project the data I want, and to create a new form. This is also how to use the second overload of select method. These are the 2 primary overloads of the select method, a fundamental tool in LINQ that we will frequently use throughout this course. As we progress, you will encounter more examples demonstrating the versatility of this method. Now, let's summarize what we have learned about these overloads. The first overload is used to project each element of a sequence into a new form. This projection can be as simple as selecting a single property from each element, or as complex as transforming each element into a new type or shape based on a specified expression. The second overload extends the functionality of the first by introducing an index parameter. This index represents the position of each element within the source sequence. The presence of this index parameter allows us to incorporate the element's position in our projection logic, enabling more sophisticated scenarios, where the order or position of elements is crucial. In both cases, the expression provided to the select method determines the nature of the projection. It can be as straightforward as returning the element itself, or it might involve intricate calculations or transformations, depending on the requirements of your query. Understanding these overloads empowers you to reshape and manipulate data sequences effectively, a skill that will prove invaluable as we delve deeper into LINQ's capabilities in this course. The last point I want to mention in this video is a very useful feature of select method, which is similar to LINQ clause, what we have learned in a previous video. LINQ clause is a powerful feature for introducing new variables into our queries. Before we explore this feature of select method, let's do a quick recap on the LINQ clause. The LINQ clause in LINQ is used for storing the result of an expression in a variable within a query. This is particularly useful when you have a complex expression that you need to use multiple times in a query. By using let, you can compute the expression once, store it in a variable, and then reuse that variable, making your query more efficient and readable. Let's check the following example to see the power of LINQ clause. I have the following table. Suppose I want to filter the table to retrieve only the rows where the age is greater than the average age of the whole table, and smaller than 40. I will do that without using LINQ clause. Here's the query using mixed syntax. As you can see, I have the following expression, where I am comparing the age column with the average age of the whole table, and also the age column with the number 40. The average of the age column is 30.25. The result of this query is the following table, which contains only these two rows. Let's now do the same but using LINQ clause. I used here two LINQ clauses. In the first one I define the content of column age. In the next one I am calculating the average of the column age. In where clause I used both variables to set the condition, what I defined in the LINQ clauses. As you can see, this query is more readable and easier to follow. This query is very simple, but in some cases we may need to do more calculations. Using LINQ clause, the query is more efficient and readable. Now, having explored the LINQ clause's utility in our queries, let's turn our attention to a similar yet distinct feature in the select method. This feature is the use of 𝗬 within the select method. Much like the LINQ clause, 𝗬 in select enhances our ability to introduce new variables and shape our data, but it does so in the context of projecting each element of a sequence into a new form. In the select method, we often use either of its overloads along with 𝗬. This powerful combination allows us to define new variables within the projection. These variables can then be used immediately within the query or in subsequent methods, greatly improving the readability and manageability of our LINQ queries. So, when we write select, followed by a lambda expression, and then 𝗬, we are essentially transforming our data and introducing new tailored elements into our query. Inside the braces of 𝗬, we define the variables we need. This could be a simple transformation, a complex calculation, or even a combination of multiple fields. Let's delve into an example to see this feature in action and appreciate its effectiveness. I have the following list of products. Suppose I want to retrieve only the products, which start with letter G and end with letter R, and have a length of more than 5 characters. Here's the query to do that. Let's break it down and understand how does it work. First I have the source data, which is the input list I want to filter. After that I use select method to project the data I need. Here I used 𝗬 to define new variables based on the data I have. First I defined a variable called name, which is the product name. So, here I only use the variable x, which represents the product name. Then I defined another variable to get the length of the product name. The next variable is to get the first character of the product name. And the last variable is to get the last character of the product name. This means, the original list is transformed to a new one, which is the following. It's a collection of anonymous type. As you can see, we have a new form of the list, where each product name has now 4 properties. Now, in the next methods inside the query, we will use this collection to do the next steps. 𝗪 method will filter this collection to retrieve the names we need. As you can see, I use the properties I defined before to set the condition. The result of 𝗪 method will be only these 2 items. This means, the collection is now as following. I need to get the output as list again, which contains only the product names. Therefore I use select method again, to retrieve only the product names from this collection. So, here I used again the property name to retrieve the product names. The collection will be as following. This will be also converted to list using the toList method. So, this will be the output of the query. Now, suppose we want to sort this output list using 2 criteria, by length and then by name. We can achieve this as follows. Here, we're reusing the length and name properties for sorting. This demonstrates how variables defined in a select method can be utilized in subsequent methods. Using 𝗬 is particularly beneficial when working with data tables and XML, as it enhances the readability of the query. However, as you can see, it's applicable to any data type. As mentioned earlier, this video focuses on the select method, not the select clause, which I covered in a previous video. While the select clause can also use 𝗬 for data transformation, its necessity is lessened by the presence of the let clause. 𝗬 within a select clause is most useful when we need an anonymous collection as output. And that concludes our exploration of the select method in LINQ.